5.1, we are moving into talking about equations. Okay, last topic we were talking about expressions, and now we're talking about equations. So we had expressions and we have equations. Okay, the difference is that expressions don't have an equal sign and equations do. Okay, otherwise everything else is the same. We're going to combine like terms, we're going to distribute, we might even factor, and all of that fun stuff. Okay, we're going to be writing those equations in 5.1, and then we'll work on solving them afterwards. So 5.1 is all about writing them, and then we'll move on to how to solve them. So equations, not expressions, they actually equal something. So if we look at this first problem here, it says Cole buys a new laptop for $335. He makes a down payment of $50 and pays the rest in 6 equal monthly payments, which are P. What equation represents a relationship between the cost of the laptop and Cole's payments? Okay, in order to be successful at writing these equations, you have to be able to pick out the important things in the sentence. So Cole buys a laptop for $335. Numbers are always going to be important. Okay, as well as variables, a letter by itself. And then we also have this $50 and pays the rest in 6 equal monthly payments P. Okay, that's all going to be important. So down here, if we look at the next line, it says the cost equals something plus something else times the monthly number of payments. Well, we know he's making 6, so that one's easy. We can put a 6 there. Okay, the cost equals, well, he has those 6 monthly payments and he's making a down payment. Okay, so he already has this 50, and we're going to add his current $50 to whatever he pays 6 times for 6 months. Okay, if we want to look at this bar graph up here, it would be 335, 50, and then 1, 2, 3, 4, 5, 6 P's. Okay, so if we go down to the next row over here with the blanks, it's going to say the cost. Okay, this is where the cost was, and we know the cost is $335, and that is equal to 50 times or plus 6 times monthly payment used to be in the last one, and monthly payment is represented by P. Okay, the next step, last step in writing this equation is going to just do 335 equals 50 plus 6 times P is 6P. Okay, that's it. That's all there is to it. Writing equations. We've done this in bell ringers, so we can do it here. I'm going to erase this stuff. I'm going to try to erase it quickly. And then scroll down here and see what it says about convince me. Okay, it says convince me. Why are both multiplication and addition used in the equation that represents Cole's monthly payment? Okay, we use multiplication because he's doing the same thing multiple times. That's those monthly payments. We use addition because he's doing something else as well. He's doing this down payment and monthly payments, and means add. So that's why we have both. So let's look at another problem here. Skip over that video. All right, Marcia and Tamara are running a race. Marcia has run 4 kilometers. Tamara has completed 3/4 of the race and is 2.5 kilometers ahead of Marcia. Write an equation that represents the relationship between the distances each girl has run. Let K represent the total length of the race in kilometers. Okay, yes, it's still January 25th. Yes, I still have a cold, so I'm probably going to cough and clear my throat numerous times in this video. So we have Marcia and we have Tamara. Marcia has run 4 kilometers. Remember, those numbers in the problems are going to be important, as well as the letter by itself. Marcia has run 4 kilometers. We don't know how much of the race that is. We just know she's gone 4 kilometers. Okay, Tamara has completed 3/4 of the race and is 2.5 kilometers ahead of Marcia. So we can find out how much Tamara has run so far. She is at 4 plus 2.5, which would be 6.5. Okay, so Marcia's at 4, Tamara's at 6.5. We need to find out the whole length of the race. Okay, so we have what is the length of the race is what equals K means. What is the length of the race? The length of the race is K. Okay, so they're going to mean the same thing. We have to set up the equation. So we know that Tamara has run 6.5 kilometers of the race, and that is 3/4 of the whole race. Okay, so if we think of those part equals percent times whole questions, we have 6.5 is the part, whole times the percent. 3/4 is 75%, which is 0.75. Okay, so we have to have this equation say equals k. We could use this one, okay, or we can represent it as a something equals k by just rewriting. What is the opposite of multiplying by 0.75? Well, that would be to divide by 0.75. We're left with 1, and k times 1 is just k, and 6.5 divided by 0.75 is going to be an 8.666, repeating. Okay, how did I do that? Well, how many 7.5s go into 6.5? Remember to use, we have to make these whole, so we have to move this 2 spots, or 650 and 75. Okay, how many 75s go into 650? Well, I know that 2 is 150, which means that 4 is 300. Okay, I'm halfway there, which I know that 8 is 600. So it goes into it 8 times, and it's 600. 650 minus 600 is 50. Bring down a 0. 500. Okay, I know it's going to be somewhere between 4 and 8 because one's 300 and one's 600. So let's try 6. Okay, so I know that 4 4 is 300, 2 is 150, so 6 has to be 450. All right, that's less than 500 and within less than 75, so I'm going to be a point. Here's my decimal. It was there, right? It goes up there. We went into it, we said 6 times, which is 450. We're going to subtract, get 50, get 500 again, 6, etc. That's why it's 8.66666, repeating. Okay, so it didn't even tell us to solve it, but we know we wrote the equation first. So we had 6.5 equals k times 7.5, or we had solved the solution, and it is 8.6 repeating. Okay, so if we move on to another question, we've got example 3. So we're going to erase this here. I'll do it this way this time. Oh, you're kidding me. Erase, there we go. Erase. Yeah. Okay. Next one. Claire bought 8 tickets for a total cost of $104. She had used a coupon code to get $3 off each ticket. Let X be the original cost of each ticket. Which of the following equations correctly represents the situation? Okay, well, did she buy 3 of the same thing? 8 of the same thing and then subtracted 3 from it? Or bought 8 of the same thing? Okay, well, we know she bought 8 tickets. Okay, so we know it's either this one or this one. And did she lose $3 from off $3 total or $3 from each ticket? Well, she got $3 off each ticket is what it says here. So we know it's this equation here. And we know the total cost is $104. And it's either one of these. 8 tickets times the cost per ticket minus a total discount of $3. No, it was 8 tickets and times the difference of the cost per ticket and $3. Okay, if we look at this last one, I don't know why this is over there. It should be over there. So we don't get mixed up. This right here should actually be right there. Okay, so at the mall, Claire buys a hat that is 60% off and socks that are reduced to $5.49. Together, she spends a total of this. Let X be the cost of the hat. How much did she spend on her shopping trip? Okay, we have these three choices. So when we think about 60% off, that means find it and subtract, or find the opposite. Opposite of 60 would be 40. 40, struggling. 40%. Okay, so we can use that. We know the socks, they're just $5.49, and we know the total. Okay, so we know the total has to be $9.49, which really narrows it down because this is the only one that says equals $9.49. Here's the socks though, that's right, and here is 40% of the hat. We didn't find it and subtract anything, so the opposite would just be to find 40%. Okay, so 5.1 is all about writing expressions, turning the words into equations.